start. Thank you for coming to my session. 5 years ago, I got a new offer, a new job offer. It was in Komerční Banka, and my task and the reason why I accepted was that I got an opportunity to build a new team of the best data scientists I could find and data engineers. And we were allowed to suggest the best tools we would like to use for our work to be most efficient. And today I would like to share with you what resulted out of that and also some steps on our way how we got to here. So this is what I am going to share. First of all, I'll somehow give you the context of the bank and our journey. Secondly, I'll be giving you some hints about how we leverage Dataiku in a standardized way. And lastly, I'll outline 5 real-life use cases which we have been working on and which we have developed with the help of Dataiku. Komerční Banka is one of the top three Czech banks on the Czech market. We are top number 1 in corporate banking, number 3 in retail banking, having 2.2 million customers within the financial group. Out of that, we have 1.6 million customers within the main bank where I work. And we have more than 200 branches in the Czech Republic, and we contribute quite a nice portion of profits to the Société Générale group. To outline or to point out one important thing which is happening at this time and has been happening the whole time actually I am within the bank, it would be the digital transformation of the bank. It's touching the whole bank. We are changing the main core banking systems of the bank, and not only the core banking systems, but also it changes the processes around it, it changes products, it changes the front-end systems of internet banking, mobile banking, and also for branch advisors. And now we are coming to the final stage. We have already migrated more than 600,000 clients to the new platform. Until the end of this year, we want to have more than 1 million clients on the platform. So you can imagine that this is really a big project running the whole time, a whole 5 years long, even longer than this. And it's affecting the environment in which we can implement artificial intelligence. Of course, once it will be implemented, everything should be simpler for the bank, for the customers, the processes, the products, and everything should be standardized, and it should be much easier to operate in the future environment. Just now, we have 2 systems, the old system and the new system, so it's actually at the moment much more complex than it could be without that. So now let's go a bit deeper into where we are now. And now I would like to describe our organizational structure a bit. This is a kind of a logical organizational structure we have. It's consisting of one central AI hub consisting of 3 teams. I am the product owner of the artificial intelligence team, or squad, if you like. We call them squads. We have 2 more squads. It's cognitive and big data solutions squad and conversational platform squad in the center. We are taking care for the platforms, for methodology and how to work with the platforms. And then we have around some other teams in retail banking, corporate banking, and other parts of the bank and financial group who are using the models, or maybe sometimes they even have their own data scientists who work for those spokes, let's say, for the other teams. We enjoy great support from the top management, especially in these days and in this year. We came with a new AI strategy for the bank, and it resulted in dedicating a separated budget for artificial intelligence for the next year. So we are having this already approved, and we are planning our activities towards main topics, main areas where we will focus in the next year. For the whole bank at the moment, we have about 10 data scientists, 5 data engineers that directly supporting them, 2 conversational specialists. But I believe that these numbers will grow in the future years significantly. I would like to focus a bit on the AI squad, where I am the product owner. Our mission is not only to support the tools like Dataiku and to define the methodology, but also we deliver real use cases for different parts of the bank, especially for those parts of the bank and financial group which don't have their own data scientists. There we can step instead of, for example, supplier companies who would like to charge a lot of money for their services. We have quite good tools as the hub, which we take care for. We have IBM Watson for conversational platform, for chatbot and voicebot functionality. We are implementing it right now. We have the Microsoft tools, Microsoft Cognitive Services, Microsoft Azure Cognitive Services. And we have different tools like Python, PySpark, SQL, of course, R. And we use Dataiku as the platform to productionalize models which we develop using these tools. So I have mentioned some about the people. We have some about the tools and infrastructure. We have the access to our data sources in the data warehouse. We have Teradata data warehouse. We have Cloudera for the unstructured data. And I will be describing the cases we work on, just some examples. So I believe we have set the basis for being successful in the AI area. However, we are not there still, because I think we need to go further. We need to grow and build on these basics, and we need to monetize on it. And this is our next target, to show real figures which the business of the bank will perceive as a real impact, positive impact to the numbers which we can deliver using AI. There is several ways how we want to approach. One of them is, of course, the dedicated budget. But then we need to work on it somehow with our colleagues from different parts of the bank and of the financial group. And so I have drawn this path to AI monetization, how to monetize, how to start actually. And quite often when we come to a new department of the bank, a new group of users who don't know anything about AI, we need to explain. We need to do the first initiation session for them to explain what is it about. It's not just ChatGPT. Sometimes people imagine just ChatGPT is AI. We need to explain that we also have other tools like machine learning. We have also simpler AI models. We don't need to put data on the internet when we want to use AI. And these basic concepts we need to repeat over and over again to get the initial understanding. And based on that, we can generate the first set of use cases which we can start with. Our focus is always to start with some simpler use cases, easier to implement, so that we can start this cooperation somehow. Quite often for the internal departments, they don't have to pay for our services initially, like finding some resources for our mandates. We just want to make them understand what is it about to work with AI. So such a big institution as a bank, I cannot say that we would be on a certain level of development on this path with the whole bank. It's rather splitting department by department. In some departments, we are already more advanced. We went already to do further steps. We already deployed some first proof of concepts and first examples of real AI projects. In some other departments, we are in the initial state, and in other departments, we already went to the next stage of AI planning. We start to have like a real half-day workshops with them and discuss what kind of use cases would help them in the midterm, let's say. And then we plan the roadmap for realization of these use cases. They need to plan their resources. Quite often it spends over several, at least months, but sometimes to the next year, to the budgeting process of the next year, so that they have enough resources to implement it. And it's not, by far not about the money which they need to pay, like for our internal resources. Quite often, when we implement AI, we need to implement the model into some environment, into some system. And then they need to count with resources for integration with that system. And that's quite often even more money than just the money for the development of the AI tool or model itself. To be efficient in this, we of course need the good tools, and this is why we started some 4 years ago the selection process for machine learning operations platform. And this is the summary of our results, why we have chosen Dataiku, and it compares the expected things, the expected requirements to the reality. One of our most important requirements was to improve the speed to production for our machine learning models, especially the batch machine learning models. The initial state was that we needed about 1 month or even more quite often to deploy a new model after it was tested and developed by a data scientist, to deploy it into the production environment of the bank. During the POC, we realized that, or we expected that it could be just 1 click, probably, when using a platform like Dataiku. During the POC, we realized that it would require some more steps, so it's realistic to expect that we would need just a few minutes to deploy a model using a platform like Dataiku into the production environment. So we have selected Dataiku as the winner of the proof of concept. And then the current situation is that we have the need of about 2 hours to get a new model which was developed on Dataiku to production. There are some technical reasons why it is. We even know how we could get to a few minutes. It just doesn't pay off at the moment to make this extra effort in our CI/CD pipeline. But it's realistic, actually, this initial expectation. So maybe we'll move that there further later on. I'd like to point out some experiences we did with Dataiku, and some of them were a bit expected. Some of them were a bit of a surprise that Dataiku is also capable of doing this. We expected that Dataiku would connect to different data sources, and it works. It's fine. It connects to our Teradata, our Cloudera. It's no problem. We were happy that Dataiku works also with GPUs, so it's connected to the platform where we have Dataiku. It's connected to GPUs, and we use GPUs for certain use cases. Then we are using the functionality of Dataiku to deploy models as Docker images. Not always. We use it for models which need to operate in real time, but it really works. It has proven to be efficient. For this approach, we have the experience that we deploy the Docker images and let other teams to use these deployed Docker images in their applications. This has proven to be the most efficient way at the moment how to deploy real-time functioning models. We have observed quite high stability of Dataiku as such. When we don't do anything bad to it, it's stable, simply. And then I would like to point out one thing. Our data scientists are the coding people. They don't like clicking in a user interface. So there was a bit of cultural change that they had to adopt a bit. They didn't have to leave their approaches. They still can code. They can work as coders as they are used to. But they are now using the Dataiku environment, the Dataiku graphical user interface, so that it's standardized. And I'll come to this point on my next slide. We were surprised, actually, by the functionality of Dataiku web apps. We like them very much because for some reasons, for some models, the web apps are a very efficient way how to make prototypes of our models where the customers are expected to interact with the models. It's especially useful in the environment of large language models. There you quite often develop the applications in the way that they are interactive. So Dataiku web apps are really good for these POCs and pilots, and it's a really efficient way how to deploy. The next topic, Dataiku APIs. We knew about APIs initially, and it has proven to be really useful and efficient from technical point of view. We are using them for models monitoring, for example. And then we have the work standardization as a huge surprising benefit, or even bigger benefit than we expected. I'll describe it on my next slide because this is really important for us. So one of the biggest benefits really was this work standardization for standard types of models. Of course, we still have the freedom to work with Dataiku as we want when we develop new types of models which we didn't develop before. We can start from scratch. But for models where we have like the standard classification propensity model example with binary targets, it's no use to develop over and over again a new approach, data scientist by data scientist. It sounds strange, but it was the normal practice. I wouldn't say best practice. It was the practice before. Every data scientist had his or her own approach how to develop a model with different specifics. And to deploy such a unique model is always much more complicated for a data engineer compared to the situation when you have such a kind of a modeling pipeline where you can deploy models smoothly in a standardized way. We don't restrict the data scientists that they couldn't interfere with this pipeline. They are expected to start with client-based creation, and there is their creativity, how they develop, how they prepare the client base, how they prepare the targets for the models. And then they have this fully functioning pipeline of training, data preparation, model training, and it provides three types of models at the end. It provides XGBoost, Decision Forest, and CatBoost, and then it compares the results. The data scientist is free to either take the results as they come out of this standard pipeline, or then they can start fiddling about it. Maybe they wouldn't be happy about the performance. They could interact with any recipe in this pipeline if they want. But they have already standard start, and it's extremely improving the speed to fully functioning model. Earlier, we had like 1 month at least to develop a new model. With this, after 1 week, we already have several functioning models, and we can decide whether we work with it further and improve the performance or not. You can see that once we are ready or happy with the models, there are also other nodes for scoring the data and for scoring the fresh data. And this is used then for the model productionalization. So for the data engineers, this is a standard task. We always have some steps which we need to check. Our data engineers need to check several things, of course, when they deploy the new model. But it's rather checking and then deploying a standard thing. Now I would like to share our experiences and 5 specific models I have picked for you. We have dozens of different models. We have just for the previous type I have just described, we have dozens of propensity to buy or propensity to churn models, but it's kind of standard thing, so I don't want to describe that. I have picked several special models. The first one, the first example is, I would call it my pet model. I like it very much. I call it email bot. And it's dedicated to select the best template to answer the email of a client. It doesn't reply to the emails of the clients by itself. We always want to have the human in the loop, but it's suggesting the best reply. We have already identified several groups of internal employees who reply different emails of clients. We have started with the KB Komerční Banka call center. In this mailbox, they get about 7,500 emails every month. So it's quite a lot of work to reply all of them. They already had some templates, but they didn't have any automation. Now, what we brought is a new button into Outlook. It's this button with a small robot. Once they select an email, they can press this button, and after pressing the button, the model is called, and in real time it replies, would you like to reply it with with template 1, template 2, or template 3, and it describes what the templates are about. And then the user just selects the right template. Sometimes it's just one template, sometimes it might be more, as I have described. And the reply for the client is generated, sometimes even second email is generated for another department, because the reply might be, yes, we take care about your request, and the second email might be, please, the second email might be sent to another department, and it's about, please take care of this request of this client. So we have this new tool, and we have implemented it already for Komerční Banka, for our pension society, and several other teams are already requesting to have this functionality as well. My second example is about image recognition. We did this example as a proof of concept for our insurance company. And it's about identifying fraud on medical reports. The fraudulent medical reports might be analyzed or found by analyzing the signatures and stamps on the medical reports. And we have developed a model which is able to find really the stamp and signature on a document, generally. In our case, the documents are medical reports, and then it's able to compare this stamp and signature to the database of stamps and signatures we already have. Again, we have a human in the loop, so it's intended to send this result to the person who checks the correctness of these medical reports, so that the real human can decide then about whether it's problem or not, whether they should pay out the insurance premium or not. My third example is a bit technical. It's about monitoring of Informatica workflows, which support some data processes. In this case, we were tasked to analyze the situation from several points of view. First of all, the data processes are designed to work for with a certain duration. The duration is some kind of typical, but sometimes it might extend over expected duration. And we have analyzed what are the thresholds for the expected durations, and when these thresholds are exceeded, the model starts to generate alerts for, hey, this workflow might be too slow at this point in time. Second point of view was also the times when the workflows run. This can be also predicted, and the model also suggests warnings when the run times, when these workflows start earlier or later than expected. My next example is a bit special because it's about checking Visa invoices. It sounds like a piece of cake, check an invoice. But imagine the real-life situation. We, as a bank, get every week an invoice from Visa, and it has several hundreds of rows. The descriptions of the rows are tricky, and we also have a web-based price list of Visa, and they have thousands of fees on the web-based price list, with many exceptions. So we have found a way how to match this, how to match the row from the actual invoice with the price list on the web. And we have used GPT-4 for this comparison. And it's actually really efficient in finding the appropriate fee level with all these exceptions, region-based, time-based, and everything for us for the to check the actual rate on the invoice we have just got. So this is automating the way of working for those departments which check these invoices, and we believe that it will fully check these invoices in near future. My next example is about RAG. I had to give this example because it's so fancy. The opportunity is obvious. As a bank, we have many information resources within the bank. We have many internal documents on different topics, and different departments have different sets of documents where they want to search for information. Sometimes only the best experts within a department can find the appropriate information in their documents, and sometimes even they need some time to find it. We want to have a RAG system which will enable this efficient search in documents, even to branch employees. So we have started to develop a RAG. We are pretty efficient. We have used the web apps of Dataiku to prototype it. Here you can see one output of such a of our web app. In here we can just tick the areas of documents, of internal documents, where the employee wants to search. Up here we can write down a question. In this case, this is my real example. I wrote the question in English, and I got the reply in English, even though the documents are in Czech. So it's really based on the technology, and it works as expected. It gave the right answer. So this was actually my last example I wanted to give you. So now let me summarize my speech. We are quite happy that we have selected Dataiku because it has fulfilled our expectations from a machine learning operations platform. It has exceeded the expectations in some areas. Surprisingly for us, the work standardization of data scientists was one of the biggest benefits. And as a result, these 2 points, currently we have dozens of models on the Dataiku platform deployed. So just in one sentence, I would say that we are working hard to become a data-driven bank. And the vision in the future, from my perspective, is that we should become an AI-driven bank. Actually, it doesn't work on the animation because of some transformations, but within the word of AI, data is hidden the AI, if you move it properly. So that was the end of my speech. Thank you.